All right. Hello, Algebra 2. Okay, here we go. We are going to graph sine and cosine functions, real world functions, real world applications. So let me zoom in a little bit. Zoom the wrong way. Let me zoom in a little bit. Okay. Okay, this is challenging, so hang with me. We're going to be doing graphing. We are going to use, the basic trig function, y equals a sine or cosine, b times x minus c plus d. Now, so far with our graphing, we've only had b as 1, where the period is 2 pi. That will not be the case today because real life isn't like that, and the period changes. So we're gonna go with it and follow the patterns. So here we go. How does this apply in the real world? So in a port, the time between successive high tides is 12 hours and 30 minutes. So high tide to high tide, that is a period, right? So the period is 12.5 hours. Okay? Not even an even 12. Okay, but we know, let's think of what that does for us, right? We know that b, the period of any function, equals 2 pi over b. Well, we don't know what we need a b. We need to write an equation. So we have just been given the period. So we know that algebraically these two can be exchanged, right? This is true. So b equals 2 pi over the period, right? Which equals 2 pi over 12.5. Okay? Now, that is my b value. But it's awkward, right? Because I have a decimal in the denominator, and I can't leave it like that. But all that I would have to do to get a whole number on the bottom here is multiply the numerator and the denominator by 1, 2 over 2. Okay? So my period is going to be equals 4 pi over 25. And I'm sorry, I said my period. The b value of my function is that. Okay? So we are going to be writing an equation. So we need a, b, c, and d. We saw that we had a period. Periods let us find b. We just did it. Let's go find the rest of the letters. The average depth, that word average should be like, right? That average translates for us midline. The average value, the midline, which means D equals 5 meters. But at low tide, the average depth of the water is 3.8 meters. Okay, so that's our low value. It is high tide at midnight. All right, now that feels a little random, so we got to do one thing at a time. So the first thing we want to do is label our axis and our height. Let's talk about what we're doing here. Find an equation to model the water depth at this port. So what is on our y-axis, is water depth. So write that down. That is one of the most important things we do, right? Label our axis. Water depth. And this, what we are going to do time, okay? Time in hours. Now, what we want to do is let x equal the number of hours since midnight, which we have to choose t equals 0. Right? We have to choose, like a 24-hour day is arbitrary when we start graphing it, right? But we're going to say that what 0 represents on our graph is write it down, midnight. X is the hours since midnight. Okay, this is going to be X values. And then we're not going to write these X values yet because we want to write them as the X values of our function. So we need to divide up the period, which we know to be 12.5. Right, so let's hang on to that. Let's get our Y values. So this is water depth. We know that the average is 5. We can count that, right? 1, 2, 3, 4, 5. So let's write a dotted line right here. This is our midline, right? This is going to be our D value. So this is 5 feet. The water is 5 feet. Water depth in feet. Okay. Now, the low tide is 3.8 for 3.8. So let's just write little here and say 3.8, right? And we want to say, if we want to know the amplitude, our A value, this is the average, this is the low tide. Let's write it up here. The amplitude is the midline minus that minimum value, 3.8. Right? The midline, sorry, minus the 3.8. So that's going to be 5 minus 3.8 equals 1.2. Okay, so that's the distance between the midline and the minimum. So that gives me our amplitude, which is our A value. A value is 1.2. Okay, we've got A is 1.2, we've got D is 5, we've got B is 4 pi over 25. And we're just going to let C equal 0 because we're going to arrange the time on our X value such that C is going to be 0. So let's just write that. C equals 0. Okay, so let's start writing an equation. Okay, we can write an equation now. So we have Y equals 1.2A. Well, actually, before I start writing the equation, let's see, why did I choose, I'm going to write it as cosine, but why do I choose cosine? Let's go back to our description. Now we're dealing with what time? All right, the time between successive high tides, there's the period, the average depth. It is high tide at midnight. We started the graph at 0. We want high tide. So let's get the high tide. So if this was 1.2, then we're going to add 1.2 here. So let's put 6.2 is going to be the depth of the water at high tide, right? So here's what we're saying. We're starting this graph at midnight, and it's saying here, this is why they added this. It is high tide at midnight. So our first value is going to be high tide at midnight. And if I start at a max value, right, that means, look at this, I have a cosine graph, right? Because I'm going to start at the max and I'm going to keep going from there. Okay, so if I write the graph, because I have to start at midnight, and that's a high tide, then I'm going to write amplitude, cosine, and then B times X. 4 pi over 25 times X plus 5. Okay, and that's my equation. Now, I need to sketch my equation, so I do need to get my table, right? So let's write a table down here, okay? We want to find our equivalent values. So we're going to have X's. We don't have too much room on this. I should have made more room. X, Y. We're going to start at 0, okay? And we're going to have 1, 2, 3, 5 points, right? So what we want to do, we always want to add the interval. So to find the interval, we take the period divided by 4, which equals 12.5 divided by 4, which equals 3.125. That is my, let's write it, interval. Okay, so when I'm doing my table, I start at 0 and I add the interval, 3.125. And what I'm going to do is add the interval again. All right, and that's going to be 6.25. And then I'm going to add 3.125 again, and I'm going to get 9.375 added again, and I'm going to get to my end of my period, 12.5. Right? I divide it into 4 equal intervals. Now, I know that this value is going to be a maximum value, right? Which I know to be 6.2. And then my next is going to be the midline. So I'm going to come down to the midline, and that's going to be 5. And then I'm going to go to the minimum, and that's going to be 3.8. I'm going to come back up to 5, and then back up to the maximum. In one period, I go one full cycle. Okay? So we want to graph along our x-axis 2 full cycles because we want to see what's happening in a 24-hour day, right? Well, maybe a little more, 25-hour day. This is going to be a 25-hour day. Okay, so here we go. So let's just take on our x-axis every 2. We're going to put an interval at every 2 blocks. So 0. Then I'm going to turn my paper so we can read this. Just mark every 2 blocks. Okay, and just to make it easier, I'm going to contrast. I'm going to put my time values in a different color so you can see it. It's going to be 3.125. And I'm just going to go 1 decimal, right? I'm just going to go 6.3. This is the hours since midnight. Little after 3 in the morning, little after 6 in the morning, little after 9.4 in the morning, little after, now here we have 12.5, and then we have 15.6, then we have 18.7, and then we're going to have 21.8, and then we're going to have 25 hours, right? That will be 2 full cycles. Okay, and all I did for each of these numbers was just add the interval, okay? So let's now plot our points. We go from a max, and at 3.125, we go to the midline, and then we go to the minimum. And the next value, we go to the midline, and then to the max, and then to the midline, back down, and we return after 25 hours. Let's fill this in. Soft curve. Okay. Okay. So we now have a graph of the height of the water over time with our starting at midnight. Okay. Okay. So now there we go. Let's answer some questions. Use the equation in part B to recommend times for a boat with a draft of 4.2 meters, okay, to enter the port. So what we mean, if a boat has a draft of 4.2 meters, it means the water can't be less than that. So what that draft means is that water, if the boat, when your boat is coming in, you can't have water height, water depth can't be less than 4.2 or you'll get stuck, right? That's what that means. All right, so what are we going to do? We want to know when that's going to happen. So we're going to do what we do with equations. We're going to say y2 equals 4.2 meters, right? And we're going to go over here, 3.8. We're going to write this line, draw a line right here. And you're going to put that in your calculator. Let's write it in. Y2 equals 4.2. We know it means meters or feet. I'm saying meters, but then I said this was feet. Okay. Okay. So now we need to put this in our calculator because we need to know. Let's look at the points we need to know. We're just going to need these 2 points, this point and this point. Okay. So let's get these 2 values on our calculator, and we're going to equate them with times in the morning. And we see that they're about 4 hours and something either between 3 and 6, right? They're 4 point something, and this is going to be 8, set almost 8 o'clock, getting to 9 o'clock. That's what we get an approximation. But let's get this in our calculator. So you're going to take your calculator. Okay. Go to y equals, but before you go to y equals, I'm going to clear that out actually. Let's hit them. You have to be in radian mode. Okay? Because now we're doing trig graphing, we have to be in radian mode. So everybody click your mode button. Your third line down, radian and degree. Okay, so if you are in degree, right, go down. If I was in degree, mode. If I were in degree, it would look like this, right? And I would move it with the arrow, and I would hit enter, and now I'm in radian mode. Okay, now let's go to y. Let's go to y equals. Let's plug in our equation. Right, here's our equation. I'll read it to you. You have it, but on your calculator. Y1 equals 1.2 cosine. Now I'm going to put 4 pi over 25 in parentheses. Okay, so it gives you a parentheses. Make another one. Parentheses 4 pi divided by 25 end parenthesis. And then next to that, I'm going to write an x. Okay, end parenthesis. And then plus 5. Plus 5. Okay, we just want to make sure we don't get denominator issues. Okay, now let's not hit the graph button before we set the window. Right, we know our window on the x-axis 0 to 25, on the y-axis 0 to, let's make it 8, just to give ourselves some space. Okay, or 7. So let's go to the window. Let's go 0 to 25, x min 0, x max 25, y min 0, y max 7. Okay, I want to get this graph on there. And now I'm going to hit graph, and we should be getting a pretty graph. We see a positive cosine graph, right? Starting at 0 with C of 0, that's our positive cosine graph, no shift. Now, let's go to y equals and go down. We could do the midline, right? But we know the midline is y equals 5, but let's not do the midline. Let's just do the what we want, 4.2. y2 is 4.2, graph it. All right, and we're just going to do these first two values, okay? We want to know at what times we are allowed to enter the harbor such that it won't be too low, right? It's above these times. So let's do the intersection, right? Second calc intersect. Now my cursor's way over there, so I'm going to move it left, 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 left. Moving the cursor, I'm going to move it to the first intersection. I'm going to get close. Oops, got a little, doesn't matter. We get close. Enter, enter, enter. Now there it's on the intersection, and I see that it's 4.5. So I'm going to write that down. X1 equals 4.5. X2, the second intersection. Second calc intersect. Move the cursor. Moving the cursor. Getting close to the next intersection. You don't have to be exact. Enter, enter, enter. Okay, and it says 7.9. X is 7.9. And that's what we thought, right? And we're not going to make too much of these details. We are going to make an approximation. Okay, so the answer to our question is recommend times for the boat with a draft of 4.2 meters to enter the port. And we're going to say boat should enter before 4:30, 4.5, 4:30 a.m. or, right, after 8 a.m. Right? These are approximations. Okay, we put a little curly Q, but that's the idea. Okay? All right. It's a lot of detail. Let's do it again. Okay, this will get better with practice. It might feel overwhelming. It usually does. Okay, we have another type of problem. A Ferris wheel is 4 feet off the ground. It has a diameter of 26 feet, rotates once every 32 seconds. So rotates once every 32 seconds. My period alarm, that's the period, right? 32 seconds. The whole thing goes around every 32 seconds. That's the period. So I see period, so let's do the B value, right? We knew from working this above that B equals 2 pi divided by the period, which equals 2 pi divided by 32. It just simplifies the fraction, and we get pi over 16. Okay, nice. Got my B value. Okay, now a Ferris wheel is 4 feet off the ground. It has a diameter of 26 feet, rotates once every 32 seconds. Sketch the graph of your height while on the Ferris wheel. Your height from the ground while on the Ferris wheel. Be sure to label the graph. So when I work with Ferris wheels, this is what I like to do. Let's think about a Ferris wheel, okay? First of all, let's draw a Ferris wheel over here. First, we've got the ground, okay? And then we've got 4 feet. And then we get on the Ferris wheel. And we go in the air and we come back down, right? This is our Ferris wheel. We have little blocks. We're going around the Ferris wheel. We like Ferris wheels. Okay. All right. So what we want to say is we know that this is 4 feet off the ground. What else do we know? The Ferris wheel has a diameter of 26 feet. So from here to here is 26 feet. So we know that this is 13 feet, right? 4 feet, 13 feet, and this is 13 more feet, okay? Because this whole thing was 26 feet. So we've got 26 plus 4. We have a maximum at 30 feet, and we have a minimum height that when you're on the Ferris wheel of 4 feet. Okay, so let's think about that. What is our midline? Our midline height is right here at 4 plus 13. Okay, so let's label our axis. This our y-axis is height in feet, height off the ground, and over here our x-axis is the time in seconds. Okay, so let's draw we know that our max height is 30 feet, so we're going to just label our axis every 2 blocks 8 feet. So we're going to have 8, 16, 16 plus 8, 24, and then we'll have, the next one will be 32. Okay, so, okay, that's our height of 0. So let's now get a different color. I'm going to draw the midline of the graph, right? We saw that the midline is happening, the D value is happening at 17, right? Our max, our amplitude is going to be 13. Now our minimum value is going to be 4, so let's write that here. This will be our minimum value. And then we go 13, 17. 17 is going to be our midline, so let's draw that midline. Midline of our graph. And then our maximum is going to be 13 more feet, which is going to be 30, right? So that's going to be maximum, minimum, 4 feet off the ground. Okay, and I got that from the drawing of my Ferris wheel. Okay, now the x-axis is much easier this time. So we need to make a table, x, y, and draw 4 lines, 1, 2, 3, 4. Okay, we are going to start at 0, and our height at 0 when we get on the Ferris wheel is going to be 4 feet off the ground. Okay, and then we need the intervals, the time intervals. So to find the interval, we have a formula, right? It's the period divided by 4, which equals 32 seconds divided by 4, which equals 8. So we start time in seconds. We get on the Ferris wheel, and then 8 seconds later, and then we add 8, 16 seconds later, add 8, 24 seconds later. We have gone around one time in 32 seconds. Right? We took the period, we divided by 4, and what's our height? Right? Now let's make a point on the graph. We are starting at the bottom, right? Because we have to get on the Ferris wheel. So we put our 4 feet at, let's label the x-axis with our x values. And I'm going to label I'm going to stretch this out a little bit. On my x-axis, I am going to say start at 0, 4 boxes later. I'm going to put 8 seconds. This is the time in seconds. 4 boxes later, 16. 4 boxes later, 24. 4 boxes later, 32 seconds. I'm just going to spread my period on the x-axis. I don't need to do 2 periods. I could. All right. Now, so I'm going to get on, and at my next interval, I'm going to be here at the midline, 17 feet. Let's write that, 17 feet off the ground. And then 8 seconds later, I'll be at the max. 8 seconds later, I'll be back at the midline. And 8 seconds later, I'll be back on the ground. And hopefully they'll, let us go around again. So we've got a soft curve. And I hope you see, when I'm writing this equation, a negative cosine value, right? Because it's a minimum, so that makes it a negative cosine. So you want to find an equation to model the height. So we could write these down. We were 4, then we were at 17 feet, and then 30 feet, and we came back to 17 feet, and we came back down to 4 feet off the ground. Okay, let's write our equation, which we did not do, but we have all our letters, right? And again, our C is 0, because we're going to write it without any shift as a negative cosine. So write the equation. Y equals negative A value, 13, cosine. Our B value is pi over 16, pi over 16 times x, and our midline is plus 17, right? A cosine bx plus d, because our C is 0. Now, that's our graph in our equation. So how high will you be 10 seconds into the ride? Okay, well, I'm going to let my calculator do that. I can kind of estimate, right? 10, 8, 10, 12, 14. I can read it. It's kind of hard to read because I can't read it. But that's the question being asked. At 10 seconds, how high will you be? So let's do that on our calculators. Take your calculator. Go to y equals. Clear it out. Clear these two out. You are in radian mode, so you're good to go. And then we're just going to plug in this equation. Use your negative at the bottom of your calculator, right? This negative 13 cosine. Now I'm going to do parentheses again. Pi divided by 16. I'm doing the extra parentheses. Then I'm multiplying by x, and again parentheses, and then plus 17. Now I'm going to go to my window and change it because I want a window to go 0 to 32. And then I want on the x-axis, and on the y-axis I want to go to 32 because I want to be a little higher so I can see clearance. So I'm going to go 0 to 32 feet high, and now I'm going to hit the graph button. See that? There you go. Okay. And there is a function height, our height above the ground going on this roller coaster on the Ferris wheel. So let's answer the first question. How high will you be in 10 seconds? Second, calc, x equals 10, right? 10 seconds. Enter. You will be 21.9 feet off the ground. So let's say 22. How high will you be 10 seconds? Sorry, see it. So you will be second calc value, or 1x equals 10 seconds, and we got 22 feet. That is the answer to our question. You'll be 22 feet off the ground. Okay, during the first minute, when will you be 20 feet high? So this is 32 seconds. So let's just change that a little bit. During the first 32 seconds, we could extend this out, right? When will you be 20 feet high? So I'm going to go to my graph, and I am going to say, right, when will I be 20 feet high? I'm going to say y2 is 20 feet, because that's what's on my y-axis. I'm going to graph it, and I can find when I will be 20 feet high. Second calc intersection. Move it closer. Enter, enter, enter. 9.2. So 9.2 seconds. Do the second intersection. Second calc intersect. This should be feeling pretty familiar for us. Like, we've done this with every function. You know, it works the same. So I hope this is feeling like, oh, I know this part. Okay. Enter, enter, enter. So 22.8. 22.8 seconds. Right, so at these two times, we will be exactly 22 feet high in the first 32 seconds. Okay. Right. I think I am going to end this video, but these two problems, so what I want you guys to do is I want you to do these next two problems, and I will have the key available, of course, and it will be there. So so do these two practice problems. There's more practice problems that you picked up today at the beginning of class. See how far you can get. The keys will be up front for you. Okay? All right. Give it a try, and I will see you next class.